So for this question, we're given two functions, xy equals 10 and 2x plus y equals q. Q is the number. Part 1, in the case where q is 9, what is the coordinates of the points of intersection of the line and the curve? All right, so to do this, we're solving simultaneous equations. The first one, xy equals 10, and the second one, 2x plus y equals 9. We have to do substitutions, so rearrange the second equation. We'll have y equals 9 minus 2x, and then substitute it into the first equation, and we'll get x in brackets 9 minus 2x equals 10. Expand the brackets, 9x minus 2x squared equals 10, and let's move everything to the right side so that x squared becomes positive, and we'll get 0 is 2x squared minus 9x plus 10. If we're trying to factorize by inspection, we'd look for two numbers that multiply to 20. 2 times 10 is 20, and add to negative 9. The two numbers are negative 4, negative 5, which means we can break the negative 9 up into negative 4, negative 5, and that gets us 2x squared minus 4x minus 5x plus 10 equals 0. Factorizing out of the first two terms everything that we can, we'll get 2x, and in brackets x minus 2, and the second one we take minus 5 out, so we're also left with x minus 2 in the brackets, which equals 0. Now we factorize again. 2x minus 5 multiplied by x minus 2 equals 0. Using the null factor law, either one of the brackets has to be 0. So if the first one is 0, we have x is 5 on 2. If the second one is 0, we have x equals 2. To find out y, all we have to do is put x back into one of the equations. In this case, I think x times y equals 10 is pretty easy. 5 on 2 is 2.5. Multiplied by 4, you get 10, so y is 4. And 2 times 5 is 10, so for when x is 2, y is 5. Our points are 5 on 2 and 4 and 2, 5. And that's the end of part 1. Part 2 is very similar to part 1. We start with the equation again, xy equals 10, but this time we don't have a q value. So let's rearrange it to get y equals q minus 2x. Once we do that, we can substitute it straight into the first equation, and we get x in brackets q minus 2x equals 10. All right, what are we doing here? We're actually trying to solve to find points of intersection. But the question is saying, find the set of values of q which the line does not intersect the curve. So there are no points of intersection. And we're kind of doing something slightly counterintuitive. We're saying, well, let's find the points of intersection. And what you'll notice here is we're ending up with a quadratic. So let's keep going and see how this pans out. If we expand the brackets, xq minus 2x squared equals 10, move it over to the right side, so x squared becomes positive 2x squared minus qx plus 10 equals 0. Okay, so this is going to give us all of the solutions for the points of intersection. Now, one of the things we know is a quadratic may have two solutions, it may have one solution, or it may have no solutions, and we are very interested in the possibility that it has no solution, because if it has no solution, there's no points of intersection. All right, so how can we tell with a quadratic the number of solutions? We look at the discriminant, which is b squared minus 4ac. When there are no solutions for x, b squared minus 4ac is less than 0. And so that's exactly what we do. We look at the equation and say b squared, well, b is negative q, so negative q squared minus 4 times a is 2, times c is 10, is less than 0. And we have to solve that. Well, negative q squared is just going to be q squared. We can actually do that. It looks like you shouldn't be able to do that, but if you take negative q and multiply it by negative q, the two negatives cancel and you just get q times q. And this will actually work out for us later, so we should be okay. Let's take the minus 4 times 2 times 10 over to the other side. 4 times 2 is 8, times 10 is 80, so we're subtracting, we take it over and we add it, and we get q squared is less than 80. Now you may be tempted to just square root both sides and do q is less than the square root of 80, which is around 8.9. Q is less than 8.9, and that's your answer, but you wouldn't be correct. That's a mistake. Even worse, you may be So you may be tempted to do q is then less than plus or minus the square root of 80. And that again would be another mistake. So let's try and work out what's going on here. Let's draw a number line, and we'll put 80 on the number line because that's there. 0 and minus 80. Now we're going to take q, and q is a number which we square, and it's less than 80. So q is going to be fairly small, and like 9 squared is 81. It's going to be a little less than 9. So we know that q has got to be less than 9. So let's go 9 less. In this little area here, any number we square is going to become larger, and it will be, in our particular case, less than 80 because we decided that. But if we go to the right of the circle, every number that you square there is going to be greater than 80. Now, what happens with negative numbers is very similar in that negative numbers, when you square them, they actually become positive numbers. And so when we square a number between 0 and negative 9, well, 8.9, it's going to be less than positive 80. But if we go to a larger negative number, then it's not going to be less than 80, and so that's not included. All right, so we only have this little region here where we have valid answers for q. How do we write that? Well, we can write it as q is less than the square root of 80 and q is greater than negative root 80. Now we have to write and because it has to meet both of those criteria at the same time. There is a nicer way of writing that without using the word and. We can write, root 80 is 4 root 5 if we simplify the surd, and we could write q is going to be larger than negative 4 root 5 and q is less than positive 4 root 5. Or if we wanted to give approximate answers, q is larger than negative 8.94 approximately and less than positive 8.94. And that's how we work out that question.